Hi everyone, Dusty here from Discovery Lab in Tulsa, Oklahoma for Discover at Home, a series of experiments and activities that you can do with a parent or caregiver at home. Today we're going to be looking at our Catapult engineering kits developed for the Opportunity Project. We're going to be learning about mechanical engineering as well as stored and kinetic energy. If you have the Opportunity Project kit, you should have these supplies. First of all, an instruction kit to tell us how to perform the experiment. Some skewers, popsicle sticks, an egg full of dough, a spoon, rubber bands, some muffin tin liners, pom-poms and cotton balls, a small spool of tape, and a fish. If you don't have the Opportunity Project kit, you can try and find these objects in your house or make substitutions as you need. Before we begin our experiment, we need to talk a little bit about the science involved with our activity today. We need to talk about a famous scientist by the name of Isaac Newton. He's a scientist who discovered the law of gravity by sitting under a tree and watching an apple fall. He also developed 3 laws of motion that govern just about everything in our world. The first law of motion states that an object at rest will stay at rest until acted upon by a force. My block here is at rest. It's not moving. Nothing is pushing it or making it move. The second part of the first law states that an object in motion will keep moving until acted upon by a force. So if I make my block move, it'll slide until something stops it. In this case, it was friction or rubbing against my table that made it stop. The second law of motion states that if an object has balanced forces, it will stay constant. Right now, my block is balanced. The forces pulling it this way, and that way are all balanced, so it doesn't move. But if I give it an unbalanced force, it'll move. So if I give it a little push from one side, it's going to knock it off balance. You can see it wobbles. Then it returns to balance as those forces rebalance themselves. The third part of the laws of motion states that whenever an object has a force acting on it, an equal and opposite force pushes back. That means that if I push down on my block, my table actually pushes up the same amount that I push down. That's equal and opposite reactions. And those are our 3 laws of motion brought to you by Isaac Newton. You guys might have seen catapults before, but do you know how they work? They work through a process called stored or potential and kinetic energy. Whenever you have a rubber band and you pull it out like this, you're putting energy into it. The energy from your muscles opens it up wide. Then these rubber bands want to pull back. Do you remember what we said about the 3rd law of motion, equal and opposite? As I'm pulling these out, these rubber bands want to pull back in. Whenever I release it, it moves. That's kinetic energy. So I can store my energy and then let it go, and when it moves, it becomes kinetic energy. Our catapults are going to use all these rubber bands to store and release energy to throw our ammunition. I'm going to show you a few different ways that you can create a catapult to store and then release that energy. The first way I'm going to show you is going to be using our dough, spoon, skewers, tape, and rubber bands. Feel free to follow along with me, or if you have a better idea, I want to see what you guys come up with. For this version, I'm going to take my dough out and cut it in half with my fingers. Then pinch each half in half to make quarters or fourths. you should have 4 balls of dough that are about the same shape and size. Grab 3 of your skewers. Lay them down in a triangle shape. Use 3 balls of clay to attach the ends of your skewers together so that it makes a triangle. Like this. Next, you're going to take 3 more skewers and stick them in the tops of your dough. Grab your last ball of dough and gather the tops of your 3 skewers that are sticking up and stick it right there, like so, combining those 3. Now what you should end up with is a shape that's called a tetrahedron. You can see that each side is a triangle. I'm going to turn mine to the side so you can see it a little bit better. I'm going to press down on my dough so that way my catapult has a good sturdy base. I don't want it sliding out on me. Now let's create our arm. That's the part that holds the ammunition and launches it forward. To do that, grab your spoon and a skewer. Peel off a little bit of tape. You want to use a good amount so that way it sticks really well. You don't want your arm falling apart. Tape your spoon to the end of your skewer, making certain it's good and tight. Take 1 of your rubber bands and set it over the top of your tetrahedron. Now, this is the tricky part. You're going to want to stick this skewer through the rubber band and then into this dough ball right here. So you should end up with this skewer sticking out, attached to your spoon, that then goes through this rubber band. If you've been following along, you should have something that looks a little bit like this. You can see how my spoon goes straight through my rubber band and this skewer is attached right here. My rubber band is going to supply all of my stored energy because whenever I pull down against it, the elastic of the rubber band is going to hold on to that energy until I let go of it, and it's converted into kinetic or moving energy. Before we launch something out of our catapult, let's talk a little bit about the forces that are involved. Let's talk again about Isaac Newton's 3 laws of motion. Is my catapult moving or is it at rest? Right now, it's at rest. It's not moving. It's not going to move until a force acts upon it. In this case, the force is going to be my hand pushing it down. Second law of motion, balanced and unbalanced. If I have balanced forces, if me pulling down is equal to it being pulling up, it's not going to move. It's going to stay still. However, as soon as those forces become unbalanced, that's when it moves. As soon as the rubber band is pulling more than anything else is trying to push it down, it's going to move. Last but not least, the third part of that. Whenever I push down, the equal and opposite reaction means that this is pulling up just as hard. So it's got just as much energy as I put into it pulling it down. So that means the further I pull it down, the more energy is stored that then can be released. Let's go ahead and launch something using our catapult. Place your ammunition in the cradle, push it down, and then release. That flew pretty well. You noticed how my ball kept flying until it hits the ground, then it stops. Again, that's Newton's first law of motion. It was an object moving or in motion, and it wanted to keep moving until something stopped it. In this case, the ground stopped it. You guys can try this if you want to come up with some good challenges. For instance, trying to get furthest distance, most accuracy, or launching even heavier objects. Go right ahead. I'm going to show you another way that we can create a catapult. Let's do our catapults a different way. For this one, you're going to need your popsicle sticks, rubber bands, spoon, tape. All right, now this is a much smaller version, meaning that it's not going to be able to store as much energy. And it's going to store energy in a different way, but it's a bit easier to move around. This one is probably best to do a couple of on-the-fly shots with. Start by grabbing several of your sticks. I'm going to grab 6. We're going to make a wedge. That means we just need a really thick chunk to be in between things. Taking your rubber bands, wrap both ends super tightly. You don't want these guys to have any movement at all. You just want them to be a really big, thick chunk of wood. Like so. You can see they don't slide very well at all. Next, you're going to take your spoon and another popsicle stick. Gently wrap the end of this. This one you don't want to have too tight. You do want this end to move a little bit, so wrap it a lot less than you did the other ones. You can see these guys will still stretch and move a little bit. This one you want solid. This one you want to be able to move. All right, you're going to take and hold this part with the spoon and this part, the wedge, perpendicular. See how they make a little X or a T shape or make kind of a cross? That is what we call perpendicular. There are right angles or square corners at every single side. Open up the popsicle stick and shove your wedge in between there. All right, you should have something that looks a little bit like this. Hold it with one hand and grab another rubber band. Thread it around the bottom popsicle stick and twist it up over your spoon several times. See how I'm just kind of going back and forth? You just want something to hold that spoon on so your wedge doesn't slip out. All right, so there we go. That's my smaller catapult that I've made right there. You can see that it still gets all of its energy from this rubber band. However, it gets a different amount. Whenever I push down, this resists movement, so it stores energy. When I let go, it's able to release it as kinetic energy. Let's see how this one works. That one launched pretty far. If you didn't want to use rubber bands around the ends, you could use the tape as well. Or if you wanted to use glue, you could. You notice this guy launches a lot differently than this one did. That's due to the angle at the end of its swing. This one is pointed more up. This one was pointed more out. Can you see how this angle is taller than this angle? This angle is much flatter. So whenever it releases, it launches my ball high into the air and arcs. This one launches it more direct or straight. Whenever we're launching something with our catapult, it has what we call parabolic motion or a parabolic arc. Just like whenever someone kicks a ball, hits a ball, or launches anything, it flies up high into the air until eventually all the forces acting on it begin to slow it down. Wind, friction, other things like that will cause it to lose momentum until eventually the thing that's acting on it the hardest is gravity. Gravity begins to pull it down. So if we could trace the launch from here, we would see it arcs up so high until it starts to slow down, and then it comes back down in kind of a big U shape. That's a parabola. So that's what we call this, a parabolic arc that it travels along. See if you guys can see that in other things, like a football or baseball outside. Now that you guys have created your catapults and we've discussed the physics behind how they work, let's try some challenges with it. On the printout you would receive with the Opportunity Project kit, you can see we've created a bullseye. The middle is worth 20 points. Outside of that is 10 points. And the very outer ring is 5 points. You can just lay this paper on the floor and try and aim at it, or you can create your own version. Set it about 3 feet away. Alternatively, you could set up buckets or hoops to shoot in. That's why we've provided you with these muffin tin liners. You can see they've got a little shark on them, and we've given you a fish to try and feed to your shark. You can try these challenges or create your own. Let's see how my catapult does. I'm going to start off with a fish first. Went a little off, but that's okay. I can sight it in later. I'm going to try my cotton balls towards my bullseye now. Overshot that one. I added too much energy to it. That means I need to push down less. So that way there's less energy. Did you guys see that arc? Just like a big upside down U, wasn't it? Too far again. This time, I'm just going to barely push down. Oh, that one hit it right in the middle. 20 points for me. So, if you guys do this challenge, add up your points through all of your shots. See if you can get the highest score. Or you can set your fish further away and try and feed them from all the way across the room. See if you can make it further than I did. Hopefully all you guys made a working catapult. I look forward to having a Zoom call with you guys and hearing about the most fun and the most difficult parts. Do you guys have any questions for me? How would you take this experiment and make it even bigger or better? I'm excited to hear your ideas. That's going to do it for our catapult engineering activity. Hopefully you guys have had a lot of fun. I've been Mr. Dusty. Thanks for hanging out, guys.